All right, everybody. So I think that we can start already now, and I guess we'll be able to uplift the recording. So hello, everybody, to this RDA session for the EGAT. EGAT stands for the Improved Data for Agriculture, in short. And for this plenary, we collected some of the topics around the ethics and agri-semantics. That is following the discussion that we had in the previous plenaries and sessions. We'll go through that in a second. I cannot go through the slides. Cynthia, you're sharing. Yeah.
Ask Jennifer to advance.
Yeah.
Just say next slide.
Yeah. So as we go through this session, there's a link here for these collaborative notes. In case the link is not in the chat now, I'm sending this again.
Jennifer, can you go to the next slide? Oh, there it is. I'm sorry. Can you go back, please? I'm sorry.
Yeah. So I put a link to the collaborative notes and please provide your names in this document, and we'll feel free also to provide any feedback and any inputs for this notes that will be shared after the meeting and follow up if needed. So use this link from the chat, or here you have the QR code we can scan. And I repeat that link several times if needed also. Please go to the next slide. So for today's session, we have, as mentioned, these two main sets of presentations. We'll go first with the introduction of what was happening recently in this EGAT community, and also some insight to the warfare project. And then focus on these two topics, which is ethics in the agriculture research data, which will be led by Alan Moss. And here we are going to discuss a potential new working group on the ethics in the agriculture, and then we'll go through this agriculture and semantics for artificial intelligence with several of these notable speakers and quite interesting talks, I believe. Next slide, please. So coming back to the last year and the discussion we had, we have started actually with pre-meeting before these annual sessions. We were collecting topics that we want to cover in these RDA sessions and potential activities that we can take. So for the last year, we had now the set of recordings on the YouTube. You can also use the link in here, but you can also look for this EGAT COP third annual meeting in YouTube channel. There's a playlist. You can go through all of these recordings online. So that's a couple of hours of good talks and good discussions. There we tackled a little bit the agri-semantics. Please go to the next slide. With some different perspective and various viewpoints on implementation of this agri-semantics, starting from this industrial perspective and quite rich knowledge graphs about agriculture. We were going through these national resources of the knowledge graphs, but also we went through some of the standardization activities. And here we heard about the lab data standards, which are harmonizing the way that the data is gathered and provided, including this semantics, but also the protocol of data collection. And there was this initial talk about the ISO Smart Farming Working Group. So as we may know, the Smart Farming Working Group is now in force. So you can also find this more recent up-to-date information about this group online. But if you want to listen what was the the intention and what is the plan of this group, you can take a look on this recordings. There are some insights that we were collecting from these sessions. Naturally, the semantic has the potential of really exploiting the data that for the moment is available but not usable. We were talking about various representations. We were talking about harmonization of the processes and data sharing and data collection. Please go to the next slide. And we also started a discussion about the ethics as the, let's say, trailer of this today's session. And also there were some quite interesting insights and challenges related to the ethics. We listened about two perspectives, about the farmer's perspective when the challenge is the ownership and awareness of the value of the data, but also about potential power balance. And we talk about also a scientific approach when data sharing is still not as common as we would like to, but is quite important for further development. And then we listen more about the policies, the governance, and implementation of the core principles, which is a good contribution to these ethical aspects. Please go to the next slide. There was a dedicated session for the recent advancement in the agriculture information system for the Eastern Europe. That session is in not in English, it's in Russian. So if you are familiar with this language, you can also listen to that session. And we were also talking about analytics and advanced solutions that take favor of all of this data that's available. But one of the challenges, it was also the imbalance of the data provision, the FAIR principles implementation, which still is an issue, and we tackled a bit of the reference data, closed data issues. There was also a session after this annual meeting about WordFair case study, and here over to Deborah, who will give you an insight into that. Please go to the next slide, and Deborah, the floor is yours.
Thanks, Peter. Hi, everyone. Welcome to our session. I'm going to talk very briefly about the WordFair project. It is a project that it's finishing this month. So it's a 2-year project that here in the IGAD community, many of us have been involved with. Was the lead of the agricultural biodiversity case study, which is highlighted in this petal diagram. And if you are interested on learning more about the project in general, tomorrow and the day after, we are having 2 sessions co-located with the RDA plenary to talk more about it. Next slide, please, Jennifer. So our case study was born here in the IGAD community of practice as we noticed that the theme of plant pollination interactions were something that was an interest of many of our communities. So it's called agricultural biodiversity, and it's more focused on pollination. So we gathered together, we gathered some institutions and groups and projects that were already working with this data. And this is our case study. Next, please. So it was divided in 2 phases, mainly the discovery phase and the pilot phase. And with the pilot phase, we also were able to produce assessment and metrics. All the deliverables from our case study are already available online in Zenodo. I will talk more about it in a minute. Next slide, please. So in the discovery phase, we conducted a landscape analysis and discovered that a huge amount of the data on plant pollination was in supplementary files of research articles, and it's not fair. in many aspects. So it's a real challenge for not only the researchers, but editorial boards and scientific societies and publishers. Next slide, please. In the pilot phase, we worked with 6 different initiatives which are listed here, and applied a strategy for data standardization. And we also produce a data assessment, a fair data assessment tool. Next slide, please. So our approach was to build on already existing initiatives. One of them is GLOBI, the Global Biotic Interactions Platform. And we also worked with a data schema already proposed by Julia Salim and collaborators, and also a vocabulary that was developed by the Brazilian Plant Pollinator Interactions Network. And we also work with GBIF in the new data model for biotic interactions for publishing interactions data. So if you are interested in learning more about what we did, we don't have time to go into deep, but we had a webinar discussing this in April last month, and it's available online. Next slide, please. We have all the data that we worked with described, and some of them freely available in the Global Interactions portal. There is a dedicated web page for our project. Next slide, please. We developed a cookbook to whoever is interested on standardizing plant pollinator interactions data. Next slide, please. Also a tutorial to standardize the plant pollinator data sets. Next slide, please. A tool for assessment. It's our deliverable 10.3. Next slide, please. And all our materials are available in the World Fair Project webpage. So I'm going to put this in the chat if you are interested on learning what we did, and also in the collaborative notes. It was a great experience for IGAD to participate in this project. Thank you for your attention, and I go back to Peter.
Thanks, Deborah. Are you happy to get questions in the end of the session? I hope you'll stay. Okay, so please let's go to the next slide, and we are starting the first longer discussion about the ethics in agriculture, which is related to this community review of the new working group on the ethics in agriculture. And you welcome Alan Moss, who put great effort to prepare this whole idea of the working group, and will present some of these ideas here. Alan, are you?
Yep, I'm here.
Online?
Thank you.
Over to you then.
Thanks. Hi, everyone. My name is Alan Moss. I'm a AAAS Science and Technology Policy Fellow, and I'm placed with the United States Department of Agriculture. And I'm working with Cindy, who's on the line too, and helped organize this. So I'm one of the future co-chairs of this working group that we're currently in the development process of. It's currently under community review. So here's a link if you have any comments. We have our case statement available online, so you can take a look at that and you can leave us notes. And if you did that before May 30th, then that would be really helpful, because then we can address them as we get hopefully established as an official recognized RDA working group. Next slide. So here's a quick overview of the case statement review process. Many of you are probably more familiar with this than I was when I first started the process. So we have already, as a group, been meeting for a few months now, and we've already developed a case statement, and we are currently in the community review process of this. And after this review process is over, then will be a possible revision, and then there'll be a larger review done by leadership, I think at RDA. And then we'll review that, and then hopefully eventually we'll be an endorsed group. Next slide. So a lot of this information is taken straight from the case, or summarized from the case statement. So it might look familiar if you take a look at the case statement as well, but I'm going to go over it, and then I'll also be collecting feedback that I can relay back to the other group members. So the purpose of the group is to, of course, work with the ethical issues related to agricultural data. And we decided to narrow the focus of this group to smallholder farmers and indigenous people. We wanted to have a narrow scope so that we could be focused. And then this was also the top priority of a lot of the members of the group, was these underrepresented groups, often in processes like this. Yeah, so we have our justification here that these groups are often expected to contribute data and often don't have voice in the process. So we're hoping to fix that. Next slide. So the mission of the group is to improve the ethical treatment of data. The way that we plan on doing that is by convening a diverse group of interest groups. And when you see our group membership currently, you can see that we represent a wide variety of regions and different areas and expertise. And the final objective is to create a framework of guidelines and recommendations. So specifically RDA recommendations, I think, is the typical recognized output, and that is officially endorsed recommendations by the Research Data Alliance. So that is hopefully what our results will be from this working group. Next slide. So the beneficiaries of this are diverse. So they are, of course, the institutions that are seeking guidance and how to better collect, use, process, share data. There'll be the researchers who are actually in the field collecting this data and using it and implementing the actual standards. And then there'll be the farmers who will hopefully have better data protections and have a better say in the process. And also recognizing them that they're not just the data producers, but they're also kind of the collaborators and producers, and that they could potentially also be the end users of this data. Next slide. So the group's project and work, which will take place over the next 18 months, is to engage with existing work in the area is the first part of the process. So there we're going to do a landscape analysis of existing literature and research and other reports in this, but then we're also going to look at other RDA groups that are currently working on related areas. So there are 3 listed here: the ethics and social aspects of data interest group, the sensitive data interest group, and the AI and data visitation working group. We'll also be reviewing previous work by several other different partnerships. So there are several of the members that have been working in this area for a long time, and they have a lot more expertise or they have a lot of expertise in this field. We'll also be holding discussions, and hope is also to have focus groups. And then we're also looking at other possible engagement to engage with existing work. So if you have any ideas, this would be a helpful area to get feedback on at the end. Next slide. So every working group needs to address or is supposed to focus on addressing one or more of the UN Sustainable Development Goals, which there are 17 goals. Next slide. And these are the 4 that we pulled out as being the ones that we would be most directly addressing. So zero hunger is pretty obvious for an agriculture focused group. Industry, innovation, and infrastructure, of course, making data collection and processes more streamlined and easier to do. Reduced inequalities, as I mentioned, we're focusing on small stakeholder farmers and indigenous groups. And then peace, justice, and strong institutions. As we're developing up and building up institutions by giving them frameworks that they can use. Next slide. Okay, well, kind of went over this. So next slide. So here are the current members of the working group. As you can see, we've been having several meetings so far, and as you can see, we represent a pretty wide variety of areas of the world, with a few noticeable missing areas. We don't have great representation right now from South America, from Australia, from Asia. So we are looking for adding more members to the group, and at the end, you'll be able to see how you can join the group, and we'd be very welcome to have you join our group. Next slide. So we're currently under community review. Here's that link again. Our meeting started in just last December, at the beginning of December. We meet monthly on the third Tuesday of every month, and we're meeting at this time. If you'd like to join the group, I encourage you to reach out to me, and I'm available at alanmoss@usda.gov, or Valeria. She is the other co-chair for the group. And I think we might have another slide too, because we left in some time to have a discussion and to open this up for everybody. And I think we have another 9 minutes. Is that correct?
Yeah, that's exactly fine. So yeah, we have this 8 minutes for discussion and thoughts about the working group feedback. I have some questions. Well, I was in the discussion, but I still have some questions. But maybe there are some other from the audience. If not,
Oh,
There is one
Yeah.
hand raised.
Ryan, go ahead.
Disappear for a second. Hi, Alan. Yeah, it's not so much a question as such as just that I haven't had a chance to review the case statement yet, but there is obviously you mentioned a few groups there that the group would be interested in interacting with. Just wanted to add to that, there's the Indigenous Data Sovereignty Group, interest group. So I'll put a link to that in the chat. I'm sure you might have come across this group already, but it's just probably worth adding to the list of groups.
Oh, thank you. Yeah, I appreciate that. That's in my other part of my job. I've been working with that at the USDA right now. We're working on that, some of those issues. So I appreciate that connection.
yeah, so one maybe question I would have is how do we follow up with these onboarding of different groups? We are in the phase of the review, so we can already gather some feedback, but I understand that we'll go through this process along this year. The group is planned for how long? Can you remind us?
Most interest groups need to have work on 18-month timelines and have deliverables. The plan is to have our deliverables ready about the halfway point of that, so that we can well, actually earlier than that, so then we can get feedback and then hopefully have the final deliverables ready about halfway through. And then that way we can have the second half of the interest group, the second 9 months, focus on implementation and rollout and sharing and things like that. So we don't want to just end with the deliverables and then stop. It's part of the process. Cindy?
Yeah, so I understand that last week in RDA, there was an ad hoc gathering of some people who are interested in agricultural data integrity. And I didn't find out about it in time, so I wasn't able to join that meeting. But it sounded like there might be some overlap there. So in particular, they sounded like they were very interested in questions about attribution of data for people who are contributing data, such as farmers, and other issues like that. And I'm wondering, I don't see the organizer of that discussion here today, but I'm wondering if anybody here was able to join that impromptu discussion. I'll see if I can find a link to it and put it in the chat. But was anybody here able to be there? Deborah, I know you saw the discussion, but I don't think you were able to be there.
Yeah, I did not participate. David Molek was the one convening it.
Right, right. And he actually works for the same agency that Alan and I both do. So we should be able to discuss it with him. But I think, Alan, that's another group that, given your scope, I mean, I actually really applaud you for keeping a fairly tight scope on this group. And it may be that their scope, their interests are much broader than that, but definitely there should be some communication so that they can work with you, or you can divide the work or whatever. But they sounded like they were interested in creating another working group. And Alan, did you see anything about that? I'll send the info.
Yeah, thank you. No, I haven't been following the RDA meeting, so I'm going to do that the rest of the day to catch up.
Yeah, they said they would be here, so I don't know if maybe someone that participated there is here again. And just if you're not comfortable talking right now, just let us know so we can connect things.
Yeah, my sense is it's another group of people who are interested in these topics and may not be so involved with EGAD yet, so we can hopefully bring them all together. Actually, I will try to find the link. It's just, actually, Deborah, you have the link. Can you put it into the chat?
I just found it. I'm doing this right now.
Great. I'm just nervous about losing my screen since I'm hosting the next part of the agenda.
Okay. I also dropped a link to the community review. And if you follow that link, then you can go and find the working group listed. And then if you click on that, you can see our full framing paper, or case statement rather, and you can leave comments on that.
So the other question from my side is, you mentioned the implementation, and could you elaborate a bit more? What does it mean to implement? On which level you're going to test these outcomes?
Yeah. So I'm not familiar with the testing of these and having people use these in their experiments or data collection, that process. But as far as the communicating the recommendations, the plan was to bring that to plenary meetings like this, and then also smaller meetings through the RDA network. And then also the plan was to take it directly to institutions and organizations, because we represent a wide variety of institutions. So the plan was to meet with them as appropriate, and other groups, to try to have a wide impact. Ryan, I saw your hand popped up, but it popped back down, so maybe don't.
Yeah, apologies. I didn't want to interrupt you with your answer to Peter. Yeah, just the one thing, if the last point I'll bring up. So obviously this working group is in its kind of initial sort of startup phase, but the RDA Tiger project that I'm working on as part of RDA Europe, this group will be eligible to apply for support if it is interested. So I will put a link to the call basically in the chat there. I'm happy to kind of, if you this obviously I won't take much of this meeting because there's other things on the agenda. But if you would like with one of the other co-chairs to discuss applying for support from the Tiger project or anything to do with that, please just let me know. My email's in the attendee sheet. But this group would be happy to support if you were looking to make an application.
Great, thank you so much. Yeah, one of that actually came up in a meeting a couple meetings ago was we had talked about having focus groups and interest groups. And so there might be like an in-person component of that to actually meet with stakeholders.
Yeah, no, that's definitely something we've been helping out with other groups that we've been supporting. But yeah, happy to talk about that in detail if you need.
Great, I'll bring
I guess
next group meeting.
the other topic, Alan, that we should probably look into is support for adoption. So I think that is really more about the implementation side of things, but it's not too early to be thinking about how we would, once there are recommendations, it may be that RDA can help support adoption activities of the recommendations. So let's just keep that in mind. That's actually similar to what the World Fair project was doing. And they did obviously get some financial support to help try things out. So that's something to think about.
Wonderful.
It sounds like some ideas already here, and as we are approaching 4:30 my time, I think that we can go to the next slides and the next session, part of the agrisemantics. Thanks, Alan, for this input, and we'll think in touch. Cindy, you want to take over this?
Sure. Thank you, Peter. So the rest of our time, so for the next hour, we will be having some very interesting talks and discussion about this topic, agrisemantics for artificial intelligence. And if you go to the next slide, we have 3 speakers lined up, and I will start with a brief introduction about the topic. And for those of you who are new, by agrisemantics, we mean the kinds of way of organizing data and information having to do with ontologies, linked data, knowledge graphs. Sometimes people in the past have called this the semantic web, but all of this is in the agriculture space. And EGAD previously, a number of years ago, helped launch a working group on agrisemantics, which was very active for quite a long time and has issued recommendations, which you can find on the website. But I've had an interest in the semantic web for 15, 20 years now. And one thing that I found interesting is that while this was an early kind of artificial intelligence, now with all the latest developments in technology, some people might think that all of these things, agrisemantics, are no longer relevant because we have much more powerful machine learning and generative AI. And so the question is the new round of artificial intelligence replacing what we have previously been working on with ontologies and linked data and knowledge graphs? So I think the answer is no, and I wanted to organize this session to think about what the implications are. So if you can go to the next slide. I've pulled this graph or this chart off of a Neo4j slide, and it's essentially providing some of the context for how these knowledge graphs can actually enhance the new artificial intelligence. And so I think the important things that I'm thinking about are that knowledge graphs, which I hope our speakers will talk a bit about, can provide context for decisions, for accuracy, to make sure that the AI that we're seeing today is explainable and credible. And then also, because we've already done a lot of work with more structured semantics, it could speed things up. Things could be more efficient. And all of this, I think, is really exciting to think about, but I'm really excited to learn if anybody here has actually done any of this yet. But whether they have or have not, after we hear the talks, we will have a little discussion to decide if there's interest in moving ahead with some kind of working group on this topic. And so what I will be doing is I will ask each speaker to speak for about 12 minutes, and then I will provide a warning when there's only about a minute or two left, and then we will have a few minutes for discussion, and then we'll move on to the next speaker, and then hopefully at the end of the hour, we'll have time for general discussion on the topic. So with that, if you could go to the next slide, I'll introduce our first speaker, who is Felipe Soares from University of Sao Paulo and University of Twente. And he is a graduate student earning a doctorate in computer science. And he'll be talking to us today about applying large language models in ontology design. So Felipe, take it away.
Thank you. Thank you very much for the introduction, Cindy. Can you just confirm if you can hear me?
Yes, you're good.
Thank you. So first of all, thank you very much for having me here. I will talk about this topic because it's a part of a bigger project we are developing in Brazil right now. So just for you to have like a big picture of this project, we are doing a verification of a number of data sets related to commodities trading in Brazil, agricultural commodities trading in Brazil. So many institutions across the country joined efforts, also supported by the Go Fair Brazil Agriculture Access, but also by the Center of Artificial Intelligence in São Paulo and many other institutions to try to verify this data that is basically produced every day, but by different institutions across Brazil, mostly related to price indexes for agricultural products. But the thing is, there is no standardization. So each institution published this data with their own terminology, and many times they also use like common names for the products they basically describe in these price indexes. So basically, we realized that there is like a huge gap for improvement regarding the application of the FAIR data principles. And then it was also part of the 5th Brazilian Action Plan on Open Government, which is part of the International Open Government Partnership as well. And so we have one of the goals is to create a knowledge graph with all this data from this different trading related data sets. And for that, we have many FAIR enabling resources that are under development. So we also have a metadata schema that we are using to describe these data sets. But here I will focus on this ontology that we are also creating to support the classification of this data set. And I will focus on the part that we are basically leveraging artificial intelligence or large language models to improve some tasks that were consuming lots of time from us. Well, so here, basically, as I said, the problem is the lack of common vocabulary between these institutions, and then we don't have like also accuracy for the names that they are using to describe this product, because we also know that different regions of Brazil have different terminology for the same product, and sometimes different species produce this product. So we really needed to work on common vocabulary to standardize this terminology across institutions. So next, please. Well, and then the one of the products, part of the solution that we are working is this agricultural product types ontology. But we know that there are many other ontologies in agriculture, so we don't need a new ontology in agriculture. But in this case, we are focusing on product types. So basically, this ontology is working as a classification system. And of course, we are reusing existing vocabularies as agrovoc, but mostly agrotermos, which is a sort of, it's a vocabulary for agriculture in Brazil, and it's also the terminology provider in Portuguese language to agrovoc. And basically, we are reusing their main classification structure for agricultural product types, but we are also adding new products because, of course, these vocabularies do not cover all the different types of products that we have in the very diverse Brazilian trading market regarding agriculture, because of course we have many different local species that are also part of the trading market, and they are not included. And well, but why are we so worried about species in this ontology? Well, as I told you before, we have this problem with common names, and most of the time people cannot associate the species with these common names. So and we cannot understand which product they're talking about in their data set. So basically, we are connecting these species that are related to the product in that data set. And this is nothing new because AgriVoc and Agrothermos already do it. So we are basically we are building these relationships based on these other relationships we have watched in these two vocabularies. But yeah, for us, we just realized that this relationship is very important to have more precision when we are analyzing this data set. So next, please. Well, and then we came up with, we just faced a challenge that is usually the species names in these vocabularies in Agrothermos and AgriVoc, not all of them, but some of them, when there is an update in the taxonomy, they don't reflect this update. And talking to people in Embrapa who are basically managing Agrothermos, they told me that this happened because basically they are doing this input of this of new concepts manually with a software. And well, with taxonomy data, we know that this is very, very tricky to manage because we have updates all the time. And then we are basically here proposing an approach to automate this process that can be used by other ontologies that also deal with taxonomic classification in their vocabulary. So next, please. Here's just a framework of this step of ontology design. So here's just the methodology, the reference methodology we are using, Savio, which I think is known by most of you. So I will not go in details. But yeah, in this phase of ontology design is where basically we are using ChatGPT. And so we start basically with this list of species. And then we ask ChatGPT to connect with the JBIF backbone taxonomy API. First, it has to check the accuracy of the scientific names. And if these names are outdated or are not accepted anymore, it should fetch the JBIF data, find the accepted name, and then generate the OWL ontology for that name with different taxonomic levels. Next, please. And here, and then we came up with two approaches for dealing with this data. The first approach is basically connecting ChatGPT-4 with the browser up plugin with the JBIF API and asking it to basically do this task based on all these instructions. And right now we know that the plugins are not active anymore in ChatGPT-4. So we are basically going to run this test again with the new GPTs. There is also a DPT, a browser up GPT, but as this is very new, we didn't test it yet, but we believe that we will have the same results. And of course, we will do it before publishing the paper. And so here we have the set of tasks connecting with the JBIF API, the list of taxonomic levels that it should also extract from this data, how it should build this OWL ontology with also the labels and also all the information that we wanted to have in this ontology generated by ChatGPT, and also these resources for checking synonyms and so on. So next, please. Here's just a snippet of this of how ChatGPT with browser up plugin interacted with this with the API. So basically, for each name in this list, it dispatched a query to the API and got back like a huge amount of data in JSON. And then from this data, it just selected basically the data that I wanted it to extract. Next, please. And then it generated this OWL code which worked quite well. But of course, we had many struggles on this way until we got to this point. And in the paper, we'll give more details. We can also talk about it. But next, please. And here is just an example when ChatGPT was basically dealing with names that were synonyms. Next, please. And how it responded. So basically, it said that this list of names they are synonyms. So here are the correct names, and it built the ontology with the correct names. So, but it also provided some notes on this synonymization, if I may say. So here we can see, for instance, species Prosidolus lineatus for Prosidolus scrofa. So basically, it's saying to the humans who are analyzing the code that it made this change because the name that I provided in the input was not valid. So it checked for the accepted name in the JBIF data, and then it built the ontology with the correct data. So next, please.
Felipe, you have only 2 or 3 more minutes.
Yeah, thank you, Cindy. So here we have some limitations with this first approach. So the first one is scalability. Of course, ChatGPT has a limited number of tokens that it can generate for each interaction. So in this case, we are dealing with AL files. In this experiment, we were also dealing with XML files, which are quite lengthy. And then, well, it was quite slow to generate all these small ontologies for species. And we have a list with more than 200 species, so it was taking too much time. And also to handle all these OWL files in Protege was kind of problematic because we had these duplications of labels, in the hierarchy. And we tried to merge, we tried to remove this, but it was not working well because we have also a very big ontology. And we also had problems with hallucinations, which we can also discuss later. But for instance, it was assigning like random URIs from JBIF to the concepts in the ontology. And we realized that it was mostly happening because we had like a very long list of terms. So we had to split this list and go term by term or small groups of terms of species names. And then it stopped the hallucinations. Next, please. And approach 2 is very similar to approach 1, but the only difference is that we asked ChatGPT to create a Python algorithm that could do the same thing that it was doing. So next, please. The link for the algorithm is on GitHub. It's in this slide, and then you can also find it on GitHub. Here's just an example, a snippet of how you can use. Basically, you just provide a list of species as input. Next, please. And well, it worked perfectly well with just one reservation, because you need like 100% match for all the names in the list. So if you have some typos, or for instance, for agrothermos, the Brazilian vocabulary, we have the species names with the specific epithet in the name of the species was in capital letters, so it didn't work. So before sending before running the algorithm, we have to review the list for typos and this kind of things. But we were also thinking about maybe we can use ChatGPT first to review the list of species, and then we give the input to the algorithm, and then a problem. Next slide, please, Cindy. A problem came up. So when ChatGPT is not connected to an API to structured data, it can give like some weird answers. So in this case, we just asked ChatGPT to review the names in this species list, but we didn't connect ChatGPT with the JBIF API. So it gave a very shady answer. For instance, in this case, it said that basically this species Euterpe oleaceae was like the correct name for açaí verdadeiro, which is Euterpe edulis. So it was basically saying that these species are synonyms, but they are not. So we don't know where it took this information from, but it's not accurate. So that's why it's very important to for this kind of work to have ChatGPT connected to an API of that provides like structured data such as the JBIF API. And we also believe that connecting ChatGPT with knowledge graphs will work the same way. Next, please. And well, so we still have many developments to do in this regard, but the next step is basically finishing these relationships between the product types we have in this ontology with the species. And we already released like a first version of the ontology, and we are also working on a paper describing this result. And of course, when we have this knowledge graph for the trading data, the idea is also to use ChatGPT to query this knowledge graph and test if it can provide like accurate answers from the data it can retrieve from the knowledge graph. So next, Cindy. That's all. Thank you very much. And yeah, if you have any questions.
All right. Thank you very much, Felipe. This is very fascinating. And actually, it seems almost like a circle. You can use ChatGPT or other LLMs to help you in your work. But then once these ontologies are available and accurate, they can also be used by others in their prompts, just like you were talking about using the GBIF API. Our semantics resources could also be used by others to generate more accurate responses. I'm afraid we don't have time for more questions, but we will have a little bit more time at the end for discussion. So I'm going to turn it over now to Jennifer, who is our next speaker. She's at the National Agricultural Library with USDA as a branch chief for indexing and informatics. So Jennifer, take it away.
Thanks, Cindy. Yeah, that was great. Thanks, Felipe. So I'm going to talk about our initiative at the National Ag Library with the USDA called the NALT for the Machine Age Initiative, N4MA. And NALT is the National Agricultural Library Thesaurus. And I'm just going to kind of touch on, we have a brief amount of time on some synergistic projects that we have to address our challenges with and opportunities that we have with data management and knowledge management and all the things that sort of underpin the talks here today. And our goal really is to try to develop an accessible, and by that I mean painless or maybe less painful semantic system to achieve data interoperability with all the people who aren't on this call, who really don't care for this kind of work. They just want things to just to happen magically. And so it's very difficult for them, but those are the people really who we need to engage. So we want to try to find ways, if we can, to make it as seamless as possible for them. So two things I'm going to touch on that we've done as part of our work is to refactor the NALT to a concept space. And this introduces a lot of data flexibility, which is what our users need. They want to use different vocabularies. They want, you know, that some of them don't know what the vocabularies that are available. There's a lot of issues that come when you're trying to bring this big kind of group together. So we want to give as much flexibility as we can within a standard. Sounds like an oxymoron, but that's what we're trying to do. And then I'm going to talk about our collaboration with the Partnerships for Data Innovations, which is really focusing on semantic data collection. So that's getting the structure, getting the concepts, the properties, entities. What are the schemas that are at work in the different domains, and how can we collect that as painlessly as possible? So the first thing I'll talk about is refactoring NALT into a concept space. NALT was first published in 1967, so it's a unique and valuable resource in agriculture. We do have has product values, Felipe, in NALT, which may be of interest to you. I don't remember if AgriVoc does that, but we are mapped to AgriVoc. We're mapped to the CAB thesaurus. We've collaborated with them over the years, and that's reflected in the NALT. And in 2019, we converted it from a relational model when I got here to Simple Knowledge Organization System, SCOS, which is a W3C standard. And you see Tom Baker is the consultant that I'm working with. He was one of the co-authors of that standard. So it's very helpful to have him on board to let us understand how we can really apply SCOS, even things that maybe you don't see as often. He's pretty well versed in all of that. And so part of that was making it into a concept space, which in the simplest terms is allowing for vocabularies within the vocabulary. So one of the things I come My background is more with the machines and not so much the semantics since I got to the library. And the thing that I observed is that NALT is a comprehensive, all-encompassing about agriculture, which is quite a diverse field. And so it doesn't have the granularity that you really need in some of these cases. Like we want to give some boundaries to model development. So having the vocabulary that may be domain specific, but within this system that we can use the namespace and the URIs, and we can provide all that consistency is helpful. So that's the reason behind that. We do keep the word NALT because that's our namespace. That's how we're known in Wikidata. So we're not going to change that, even though technically we're now really a concept space. We have over 77,000 preferred labels about agriculture. And as we've all heard, you know, a standard vocabulary is really the first step in any kind of data interoperability project. And that's kind of where people start to tackle it first. And then we are providing something I think that can be sustainable because the NAL can provide these persistent URIs maintained in perpetuity. And then just real quick, I think everybody probably is familiar with SCOS, but this little cloud over here in the middle of the slide is just representing a typical concept. What does the URI, that machine readable label, represent? It represents broader terms, narrower terms, related terms, and then I'm going to get into some of the newer things we're doing that will also be represented by that preferred label URI. So we bring a lot of information in it. NALT is in English and in Spanish, so we also have those translations there. So providing that single source of truth is basically what we're trying to do as all of us are talking about. So a concept space, how does this add flexibility? It provides, as I kind of described, something that's multi-dimensional. It's was modeled after GACS, so we're inspired by prior work with AgriVoc and NALT and CAB thesaurus to bring together the global agricultural concept space, which was released, I think, in about 2018. It was the first really large concept space that was put out there, and it had a GACS core, which followed. You had the full, and you had GACS core, which was a subset that followed the same top level concepts in both. And this was kind of like a Venn diagram of the three major agricultural thesauri. So it's about 15,000 terms of the most important, most used agricultural concepts. And this was validated by, you know, what was in each of the three, and also by looking at their publication repositories, which were in the millions, to look and see what was used. So this allows us, as I said, to add domain specificity with these sub-schemes. And in our concept space, we have allowed for not having to follow the top concepts. So a sub-scheme can have its own top concepts, essentially being in the middle of the graph somewhere. It doesn't have to hang from the top concepts. We can skip concepts. So if you don't need something in the middle for granularity in your area, you can do that. The only thing you really can't do is make something broader that is supposed to be narrower. So, but you can jump levels. So that is very helpful. Right now we have 4, and we're developing some more. We have the NALT full, which we now call a sub-scheme because we've developed a model where we have a file called NALT source that has all of the data. NALT full is just going to be the traditional NALT. We've promised the world we'll keep that there. We have NALT core, which does follow the same top concepts, and that's that subset that's inspired by GACS. And then we have one for the Animal Welfare Information Center at NAL. And then we have a taxon, which just is all the taxonomical names that are important to agriculture that we have in the vocabulary. We've also added now the ability to have multiple definitions, which sort of seems like, oh my gosh, how can you do that? Well, we're providing the most general definition for the NALT full. And then for these sub-schemes, they have very specific meanings that are still part of the main concept, but it's related to their domain. The example I use is, if you have the word wings, and you may have wings in natural resources, may be about drones and airplanes, and in animals, it may be about chickens, and human nutrition, it may be about wings that you put barbecue sauce on, and in pollinators, it may be about bees. So they have slightly different things, but it's still all about wings. And so we're going to be able to do that. And when we serialize the sub-schemes, we provide just that unique set of data that is for that domain. And then that will come with their specific definition. So they can have the granularity they need, but administrators, managers that want to know the whole story can still kind of roll it up to everything. And then of course, mappings, SCOS mappings, we're interested in doing that to map to all the important things. We map to Library of Congress, subject headings, agrivol, CABI, several other major vocabularies.
Jennifer, sorry to interrupt. You may have to speed up. You have only 4 more minutes.
Okay. So the USDA semantic system for data collection, this is kind of our main focus. This is infusing null concept space for an easier workflow. We're using SCOS collections, if you're aware of that. This allows us to associate. So this is another thing that will come along with that URI for each concept if it's in a collection. And this is more thinking the way a researcher thinks in collections of terms, not necessarily the hierarchy. So this is orthogonal to the hierarchy. So this makes it much easier to put these in play. It's easily derived from a spreadsheet. We're hoping eventually we may even be able to automate this. And then the goal is to get what we call a boxology diagram, is essentially a schema of their experimental design for them to review to see that we've got the semantics correct without them having to go through a bunch of crazy lists and different spreadsheets and things like that. Something that they can get a good idea if we've got that right, as well as looking at the hierarchical vocabulary. The other thing we're doing is applying a technique called punning, which allows the addition of properties, which isn't normally done, but when we're dealing with data now, not was traditionally for text, now we really need to understand what are properties, so we can use punning. I'm not going to explain how it works, but that allows us to capture that in NALT as well. And so this all supports modeling and querying with something called data shapes with Shex and Shackle, that allows us to validate data sheets coming in, that it's meeting an expected experimental design, and we are going to be able to normalize aggregated queries from across different data sets. One of the projects we're working on, Cindy talked about knowledge graph, so we're working with the NSF grant here with the University of Texas at Arlington. They have generated a knowledge graph for soil organic carbon data, which is to help us monetize this for carbon credits. It's not going to make much sense to try to mitigate climate change if they really can't get a solid value that a producer believes. So we're aggregating all this, and this has been built. And then we're also working with the pollinators with some of these, it was mentioned in here about the World Fair and looking at their vocabulary. So we're getting 2 different ways here to collect the semantic data to see if we can develop 2 different ways of doing it through a protege vocabulary and also through lists of vocabulary. And the pollinators are the ones that are challenging us to have multiple definitions. And we want those 2 knowledge graphs to talk in the end. I'm working also with the Oviedo University in Spain with Jose Emilio Labrigallo, and they're working with us to get these boxologies. This is our very first, very prototype one, and we have 2 different ways working with Partnerships for Data Innovation. They used a semantic collection system that was developed by Esri, a Survey 123 tool to collect terms in categories, whereas the WESO team worked with the researchers directly, and this is kind of the result of what those 2 approaches have done. Whereas we're working simultaneous collection and semantization with researchers. It's a very slow process, but the output is probably quite accurate. The survey, just giving them a survey and trying to pull things back quickly is fast, but that output of that schema is more semantic expert driven. So we're trying to find the sweet spot between these 2 with what we're developing with the changing our model and changing our approaches for how we collect this data. And this is just kind of a summary of what the process is. We have NALT reconciliation, obviously. I've written a NALT reconciliation algorithm, which does some of the stuff that was just described by Felipe, trying to reconcile things to a vocabulary, but this is to NALT. This is just in Python, and it provides a Levenshtein scores to help us see just string matches, and it really does a good rough preview. We can run thousands of terms through there really pretty quickly to get a first draft. And then on the left here is just a demonstration of how the collections would be done, and collections can be nested. And this kind of reflects more like how we see data. And so then the results here, just giving us a standard, flexible, standard yet flexible semantic system that researchers who don't really understand much about semantics can go to and rely on. And if they use a NALT URI, it's going to be connecting other vocabularies as well as everything more uniformly in USDA so that we can work with our data. It provides fuller semantic support. So it allows a way for our experts to be involved that are semantic experts without taking over the domain part and making sure we're divvying up that work the way so we get the best result. Increased accuracy, allowing for the domain specificity. This fast tracks this because this is a very long and lengthy and painful process, as I said. And it's providing through the collections and the data shapes with reusable semantics. So the more of these we build, the more collections we have, they can be reused. For example, if we have a collection that's everything about soil that we put together for cotton researchers who are testing the soil, and then we work with the soil researchers and they may want to add more or not, but they've already got something to look at that's already started there. So they don't have to redo everything. So this provides a foundation, kind of Felipe said, if we have sort of a structured data for large language models to use, this is what this can do. This is a human curated, which I view as this is my time, this is our time to build this, and then probably the large language models may be able to take over and do a much better job much sooner. And this also helps us meet requirements for sharing, for fair, for care, and any laws that Cindy and Alan have talked to us about that we have to comply with for various data management and knowledge management efforts at the department. So, and so just enough semantics. We're not trying to get everything down. We don't have to have every property in there. The one thing about a collection is not everything in there has to be a null right away. We can start with some. The subject of the collection will be a URI that's required, but in the properties, not necessarily. So we get just enough to get started. The goal is to get them all, but we don't have to. And then this is just my team of outside collaborators that have really helped us here at USDA with Malt for the Machine Age to get us to where we are. And that's it. Hopefully I made it within or close.
Well, we're a little bit over, but I think I will just point everybody to the chat. There's been some really good discussion there about the previous talk. So what I'll invite everybody to do is ask your questions for Jennifer in the chat, and we'll make sure to capture the chat. And that way we'll have time at the end for a round robin discussion about everything. So thank you very much, Jennifer.
Yeah, thank you for the time. I appreciate it.
Let's move on to our next speaker, who is Raul Palma. He's with the Poznan Supercomputing and Networking Center, where he is the head of data analytics and semantics. So Raul, your turn.
Yes, hello everyone. Thank you very much. Very glad to be here. So I'm going to talk a little bit today about one of the most hot topics here in Europe is regarding new initiatives and programs from the Commission that is about data spaces. And of course, in our context, agricultural data spaces. So I've been involved in many different projects related to agriculture and in particularly related data spaces in the projects defining, what is going to be the building blocks for creating a data space in agriculture. And now we are in the process of getting the implementation of this. So next slide, please. So basically, the agricultural data space is one of the initial common European data spaces that was defined by the European Strategy for Data. And it's about, of course, data sharing. So the main goal of a data space is about data sharing, a collaborative use of data for a shared goal. Obviously, this is a part of ecosystem. There are many different components that need to consume, produce, store, manage data. And all of these components need to be interconnected. They need to exchange data, right? So one of the most important aspects here is to ensure this data sovereignty and the interoperability between all of these components. Next slide, please. So one of the main aspects, of course, in terms of the implementation of data space is about the interoperability challenges. So obviously there are, especially with the new advent and progress in advances in many different technologies like IoT, big data, AI, etc. There is an explosion of data. But obviously we have a problem now how to make this data interoperable, how to make use of this data in an integrated way. So, for example, some of the key aspects or challenges hampering this kind of integrated integrated data exchange and use is basically the availability of data in different formats and represented according to different data models. So, each of the systems are producing data according to their own standards, according to their own models. So you can see even on the slides, the landscape from some years ago, very high level overview of the very large number of technologies that are available in the farm tech ecosystem. And of course, we have now also the least, one of the main aspects is about the insufficient interoperability mechanism that enable the connection of existing agri-data models. So can we go next, please? This is even further validated if we see, what is the current status in terms of the use of the data systems in agriculture. So first of all, there is a broad existing categories here. We have operational data from the field. We have data coming from farm management systems, administrative data, rural payments, etc. And again, the situation is data is highly fragmented. There is little to no interoperability between the different systems and components. And normally we have silos of data. So this is something that we are trying to deal with data spaces, right? So that, and if we go to the next slide, this is in fact one of the main aspects that the building blocks in terms of how to create a data space should address. If you see on the top of this, there is a diagram coming from the IDSA, which is providing guidelines how to create and implement data spaces. Of course, this is very ongoing thing still, but one of the main aspects, as you can see, is interoperability there. And in our projects like Agri Data Space, where we were defining particularly focused on agriculture data and spaces, we were going in a bit more in detail regarding the different levels of interoperability that we needed to address, from the basic integration and interoperability to the intermediate machine readable interoperability aspects, to a little bit more advanced using some kind of syntactic interoperability, structure APIs, to the full semantic interoperability when we are really based on using some ontologies and vocabularies behind this. If we go next. So what involves the semantic interoperability? Obviously, we know that the idea behind this is to ensure that the components and systems that are exchanging data can exchange data with unambiguous meaning, that they can understand the data, they can use this data. That's the main idea. So this involves many things, right? So starting from the common information models, ontologies, taxonomies, and so on, that was already mentioned previously in the previous talks, to these mechanisms to produce and consume the data, aligning the data to those models, and exposing those data using some kind of standard interfaces. As we know, there are many different, ontologies available in agriculture, vocabularies. Only in AgroPortal, also Clement is here. We have more than 150 semantic resources in agriculture that are, related, and somehow they have some particular purpose in many cases, right? So the main idea of the recent approaches is, instead of course creating new models, is just to enable the interoperability of relevant standards and well-known models. That's the main approach, and this is something that we have been trying to do for the last couple of years. I mean, maybe a bit more, where we created something that we call the agriculture information model. If we go next. So the agriculture information model aims to establish the basis of a common agricultural data space, enable the interoperation of different systems, and analysis of the data produced by those systems. It has a modular approach in a layer architecture. You can see here, this is available, first of all, in AgroPortal, but this is now under the process of standardization in OGC. So there is a working group there where we are trying to specify this standard based on this. It's not, as again, it's not doing generate a new model from scratch. It's aligning existing models that are, for example, coming from OGC, W3C, and putting them in a coherent way to enable the interoperability of existing data. If we go next. So the model is one thing, then we need the mechanisms to allow the, aligning of the data, harmonization of the data according to those models. And this is what we call the linked data pipelines, which allow the harmonization and integration of data, taking into account that data can be, quite, static or, dump, normally generated, but also can be very dynamic, of course. streams of data. So depending on these types of data, you could have like different process of different steps in the process of harmonization, going from the pre-processing, semantic data enrichment, mapping specifications, generation of RTF data, linking, etc. So this is, the general concept of this, and what we have done during the last years is how to implement this in a set of tools and, software that allows the, execution of those kind of pipelines in a very simple way. If you go next, this can show you a very, demo interface, how this can look like from the from a web page. But we have like command line tools, web services that are available already, and we have been testing in different projects. But one of the main steps, if you go next, is regarding the semantic data enrichment that I mentioned. And this is where also we have been playing a lot with LLMs in order to enable the, how to align the data, connect the data to different vocabularies, particularly in our case can be like agrobot, but also of course we are interested in things coming from general purpose vocabularies like weak data and so on. So we started, working with LLMs for generic purposes and then trained for name identity recognition. Similar thing we did for the part of entity linking, because this semantic enrichment is basically like a two steps. I mean, like two main steps, of course, not just two things, but it's just like two main steps. First is extracting the entities, identifying these entities, and then linking these entities to those vocabularies. And then again, we are using some kind of LLMs here, which actually the train one was created by PSNC in my institute, enabling this kind of provision of the semantic enrichment annotation. So if we go next. So going a little bit here in detail, because I think that was one of the main aspects for this particular topic today, is how we are doing all of this usage of LLMs. So basically here, the part of the entity linking, one of the first thing that we need to do is to generate the vector store. And for doing that, we do, of course, a processing of the knowledge bases. I said Wikidata, but agrobot as well. We do some embedding of the obtained profiles that we are extracting in the previous steps. We embed it as a vectors, and then we use the sentence transformer library and mixed model. And after that, we do some reduction of the size using quantization. This is some of the steps that you normally do working with the LLM. We store the generated vectors in a vector store. In particular, we use face. And of course, in the future, if we need to add new knowledge bases, because this is not going to be working only for agriculture. In our cases, we need to be able to use it in another domains in which we are having similar projects, like, I don't know, Green Deal, the ocean model, and so on. We can just generate and embed definitions just for the new entities. There is no need to repeat the whole process for all entities. So the next slide shows you how this is working in practice, of course. So you have like the input text, we run the LLM for name identity recognition. Then we apply the any def from our model that we created in PSNC. This gives us like the entity profile. Then using this embedding model, we generate the vector. And then using the vector store, we get the entity of the Wikidata entry element or agrobot entity, depending, of course, of what would be the entity that we are annotating in this case. So finally, just to close a little bit on the semantic interoperability aspect, if you go to the next slide, is that, I was talking about the models, I was talking about the tools allowing this kind of harmonization, but then the most important thing also at the end is to enable the access to this data through some kind of standard interfaces. And this is something also that we have been working during the last years, is how we can generate some way, a little bit in an automated way, interfaces that are standard. And in this case, we are again reusing standard from OGC here. And we have a service that we call the Sensor Things Generator service that allows you to automatically generate, an API compliant with the OGC Sensor Things API based on data that is coming from IIM. And IIM, of course, like I said, is not only, this connection of the models, but connections to these vocabularies like agrobot and other entities that we are connecting there. And yeah, so that's very briefly what I wanted to say here. So if you go to the next slide, I think that's the end of the presentation. Yes, so thank you very much. And yeah, happy to have questions.
Thank you, Raul. We actually do have a couple of minutes for questions. You're right on time. So does anybody have any specific questions for Raul? And then after that, we'll have time for more general discussion about the topic. So any questions, you can raise your hand. You can just jump right in if you need to. We're a small group, so. I guess I'll ask a question of you, Raul, and then maybe I can open it up to the rest of the group. My question is that now that we have, a lot of what I heard in all three talks was very much about very principled structuring of knowledge and setting up using APIs to take advantage of or to contribute to that structured knowledge. So the last couple of years have been kind of revolutionary, where the more general public who doesn't necessarily have the ability to use APIs themselves or to understand how to make data interoperable now have access to the ability to create code or the ability to actually give answers by asking a chatbot. So what has changed about your work, Raul, given these innovations, particularly with large language models?
So, I mean, in the LLMs, in our cases, we have been, trying to leverage as much as possible in how to make this kind of harmonization, alignment of the data with existing vocabularies, of course, right? So there are already some previous pre-LLMs, there were already several other solutions allowing you to do some kind of semantic annotation, of course. But with the new advent of the LLMs and all of these new technologies, we are really trying to find a little bit of more flexibility in the models that we are producing and how they can be applied, in different contexts. And as I said before, in our cases, for example, of course, agriculture is one of our main topics and domains that we are involved. But this is something that we really want to do in a way that can be reused and easily adapted to other domains. So that's something that, the LLMs allow us to do.
Okay. Let's go to the next slide. And we are going to now have a more general discussion about the topic of agrisemantics in this latest era of artificial intelligence. And I have a diagram that I want to share to maybe help us in our discussion. So I know that, Raul, you mentioned fine-tuning of these LLMs. Jennifer, could you go to the next slide? There's also an approach called retrieval augmented generation framework. This is something that we're in the process of starting to test in my agency. And the idea is that just as you would with ChatGPT, you have a prompt. So that's one area that actually you could do work to improve your prompt to get a better answer. But you can also set up this retrieval model, which would take advantage of knowledge bases, which would be essentially big collections of perhaps highly curated documents. But you could also take advantage of data sets from enterprise systems. And the idea is that you have a prompt, but you also have access to some highly accurate information that's not limited to what's in the LLM. In fact, it's probably better than what's in the LLM. And so that provides context for what you're asking the generation, the generative model. So prompt plus context. And my thinking is that if you can go to the next, click again, Jennifer. What I'm highlighting here is that I see that there is a big potential for using our agrisemantics resources in this kind of retrieval augmented generation framework. But I don't know that anybody is really experienced in how to do this. And so I'm just putting this up as perhaps a topic that a working group could take a look at. It sounds like all three of you have started to do some looking at what LLMs can do for you in your work, but you're finding that sometimes it isn't so easy and it requires some more careful approaches. So if you go to the next slide, these are the questions that I think we should talk about is, do we want a working group to actually tackle this kind of thing? What would that working group do and who could lead it? So Felipe, go ahead.
So we started doing some tests with that because a very simple test we did with ChatGPT we basically asked it to provide like the price for fed cattle in the state of São Paulo for a specific date. And well, it just made up the data. So it was not true. And we believe because the way the data is published on the web, first of all, usually these institutions, they have a robot.txt file that basically prevents like robots from accessing this data. So I think ChatGPT and other web crawlers have no access to this data. And then it just made up an answer. And we couldn't get like a precise answer for this very simple question. So basically, we created this knowledge graph. We connected also via API, and then it gave like a more precise answer because it could find the data in this knowledge graph. But this was like a very simple Sparkle query. For more complex queries, for instance, we asked it to do an analysis of the average price for fed cattle during January in 2022. Well, then the final, it created like a chart even that looked very reliable. We also checked like how the algorithm ran the analysis, and it also looked very reliable. But the thing is, the final, like the chart is slightly different from the chart that we have on the institution website. So we still have to figure out what it did wrong, because we believe that the chart that is there on the institution website is correct, because many people, specialists in statistics, did this chart. So probably there is something wrong with ChatGPT in these calculations. So we think for complex Sparkle queries, there's still a very long way to go. I don't know if any of you is also working with Sparkle and ChatGPT, but I think it's a promising future.
So I guess thanks for that. It's good to know that there's some experiments, but I guess the question is, and maybe it's too early for a working group to put together recommendations to help other people take good advantage, or maybe it's just an interest group at this point. But is there an interest, and particularly the speakers who are here today might be good to ask this question. Would it be useful for us to organize a working group to sort of tackle the question of how best to combine our agrisemantics resources with these machine learning models, these LLMs, to be effective? I see, Raul, you're nodding.
Yeah,
so
sure.
I think that it may be a little early. I think that really what the problem that I see is that, you know, they are unreliable for reasons that are difficult to understand. You know, what, like you say, what's going wrong here? And I think that the general, you know, reaction, and I don't think in people who, like, we're a technical group, so we're very focused on that it's the right answer. But a lot of the ChatGPT reaction is just instant infatuation and love, and I get an answer, and you know, and I think as the technical side of this universe, something that is really missing is what are their systematic methodologies that allow us to assess the quality of the output. What, you know, ChatGPT
well, but even how to use technology. I think that's the concern, is that it's not
well,
as
how do you
simple
know
as
how to
asking a
use it if you
question.
don't have a
Right.
way to assess what you're getting, is what I'm saying.
Okay,
And-
so
and to
assessment
do
might
like-
be a good thing to
Right.
figure
And
out.
the other thing that I think people are overlooking, because we're all in love with ChatGPT and these large language models, is that the wiki one of the Wikidata founders did an assessment, and this is, I'm not saying anything here that anybody doesn't know. If you use ChatGPT to write you a Sparkle query to query a boundaried knowledge graph, you're going to get a lot better answer than if you just ask it, but it will
Right.
give you an answer.
Right.
But the other thing is that the generative technology is that every single time you ask it something, it has to generate it. Whereas if it's like, and the example that he used was, what is Barack Obama's birthday? And you just time it. We've all done this. If you've been coding any time, you always put a timer. How long does it take? You're trying to make it efficient. And this is one little thing that no matter which one you use, it may be under a second, but you multiply that by millions and millions of times, and you're talking a lot of money. You're talking compute problems, and it takes like 4 to 5 times longer to get Barack Obama's birthday, and sometimes it's wrong. Whereas
Right.
if you just have that kind of data in a knowledge graph or in any kind of database, it's just always, it's there. You just go,
Okay.
you get it. So those are things
we have to wrap up
not being
discussion because
considered,
we're already
in my
over
view.
time now. So if we can go to the next slide. So it sounds like it may be a little early, but at the same time, we know people are using these AI assisted technologies and maybe we should help them. So let's keep that conversation going. And just a reminder that this session will be rebroadcast tomorrow at a different time, particularly to get some of the time zones that this was not too friendly for. So please make sure to join our interest group. Actually, it's improving agriculture, improving
Community of
global
practice.
agricultural data. Please join the list and you'll be brought into any future discussions. Thank you very much for attending. Thank you to our speakers and to our technical support and our RDA Association help. And thanks again. And we'll
thanks, Cindy, for putting all this together and giving the opportunity. It was I really enjoyed everybody's talks. It was great.
And thanks to
Thank you
Peter
very
for getting us started and taking charge of the first part of the agenda. So with that, I'll say goodbye, and I'm assuming somebody will stop the recording, and
The recording
we'll be in
stops
touch.
automatically when we log off.
Okay, great. All right, thanks
Yeah.
everybody.
Thank you.
Thank you very
Thank
much.
you.
Bye-bye.